Okay, so this is a lesson to go over two-step equations. We are looking at what operation should be undone first when we're solving two-step equations. So let's take a look at that. So two-step equation has two steps in order to solve it. We have two goals when we're trying to solve, when we're solving equations. One is have the variables on one side of the equal to sign and the constants on the other side of the equal to sign. And then our second goal is to get the variable all alone. So we're trying to isolate the variable and we're trying to get it all alone. So we're going to take a look at how we approach this with different problems. So here's my question. The question that I'm looking at is 2x plus 1 equals 9. And here are the steps laid out for you. So step 1 says to go ahead and box the variable. So I'm going to go ahead and draw a box around the variable right there. And I'm also going to go ahead at the same time use the same step to draw a line. So I'm going to draw a line, and I'm drawing the line right here just to keep the two sides of my equal to sign in check. Next, my step 2 is to go ahead and undo any addition or subtraction. So I'm going to undo any addition or subtraction. I can see that I am adding 1 here, so I'm going to undo that by subtracting 1. And if I do it on one side, I need to do it on the other so that I keep everything balanced. And I'm left with 2x equals 8. My next step, step 3, is to undo any multiplication or division. So I am going to undo any multiplication or division. I currently have multiplication. So I have 2x, meaning 2 times x. So I'm going to divide by 2 and divide by 2, because that makes 2 go into itself once, and I'm left with just x, and x would equal 4. So there is the solution. Now, there's also a step 5 that is not written here, but I will go ahead and add it, which is to do a check. And I'm going to do the check over on the side here. So here is the check. Remember, for the check, I'm going to use the original equation that I had, which is 2x plus 1 equals 9. And I like to always insert the value that I'm substituting in using parentheses. That way it really helps when you have negative signs and things like that, and you end up making fewer errors. So I am inserting 2 times 4 because I found x to equal 4 in when I solved the problem. So 2 times 4 plus 1 is going to equal 9. And remember, I am checking to see if that is indeed true. 2 times 4 is 8 plus 1. Does that equal 9? And 9 does indeed equal 9. Check, I'm done. All right, continuing on, here is the next page, and we've got a few more problems. So let's take a look at what we have next. Right, so here is example 2. And in example 2, let's see, I think I'm going to stick with red. It just shows up pretty well. In example 2, I'm going to follow the same process. I have this time negative 3x plus 4 equals negative 11. And I'm going to go step by step. Step 1 is to box the variable. So I'm going to go ahead and box the variable. And I'm also going to use this time to draw the line. Now I'm going to go ahead and move on to step 2, which is undo any addition or subtraction. When I say that, I'm looking at the variable, and in relation to the variable, I am undoing any addition or subtraction. So I'll introduce a little terminology here that sometimes people will use. If I take a look at something like negative 3x plus 4, let's see. I'm going to call this -3 part right here, this part that's I'm shading in green, that is the bestie. So it sticks with x, it's its coefficient, it's its bestie, it stays with it. And then the +4, which is this part right here, is an acquaintance. All right, and we get rid of the acquaintance first, and the bestie is the last to leave. All right, so we're just a way to kind of keep this in check, or keep this in mind. So I'm going to undo addition or subtraction first. So if I look at this problem, that means I am getting rid of the addition or subtraction. Currently 4 is being added, so I'm going to do the opposite operation of that, which means I am subtracting 4 from both sides. When I do that, it makes these go away because they go to happy, happy zero land, and I'm left with -3x equals, now -11 plus -4 is -15. And now I'm on to step 3, which is undo any multiplication or division. So I am going to undo multiplication by using division. Currently I have -3x, which means -3 times x. So I'm going to undo that by dividing by -3, dividing by -3. And when I do that, -3 goes into itself once. So I'm left with x equals -15 divided by -3 is +5. So x would equal 5. So therefore we solve, and we've worked out that x equals 5 in this case. Now I still want to do my step 5, which is the check. And while it seems tedious, guys, I promise you, if you do the check, you will catch problems. If you have a computation error, if you've solved problems in a way that's not correct. So here is the check. And you'll see in a minute when we do a certain type of problem where the check really is helpful. So here is the check for this. Remember, we are going to go back to our original equation, which was 3x plus 4 equals, -3x plus 4 equals -11. And I am going to insert this value that we found for x, that x was equal to 5, into it. So it's -3 times 5. Notice I put that in parentheses. Plus 4 equals -11. -3 times 5 is -15, plus 4 equals -11, and -15 plus 4 is -11, and that does equal -11, and check, I'm good. So hopefully in observing these two examples, you're noticing that I am doing these in reverse GEMDAS or PEMDAS order. So I am using the reverse of that as I am solving equations. So that's just something good to keep in mind when you're going to be solving equations. I'm going to go into a different type of problem now. Here's another example. So here is the example where we have, some division going on at this point. So slightly different format. I'm trying to use all different types of examples so that when you work independently, you have an example that you can refer to. So here is now example 3, and this time I have x over 3, which means x divided by 3 plus 1 equals 10. And I'm going to do, I'm going to follow my steps. So I'm going to first box the variable. So I'm going to go ahead and box the variable. There's that. And I'm also going to make my line at this point. So there's the line. Sorry, it's not as straight as I'd like it to be. Next, I'm going to do step 2, which is undo any addition or subtraction. So I am looking at the variable, and in terms of the variable, I can undo anything that is being added or subtracted from it. So I can see that I am currently adding 1 to it, and that's what I'm going to undo. To undo addition, I use subtraction. So I am going to subtract 1 and subtract 1. And when I do that, I am left with x over 3 equals 9. And now I'm going to take a look at this. I've got x over 3 equals 9, which really is the same as saying x divided by 3 equals 9. I'm saying that we're using the division symbol so that you can see that I now need to undo multiplication or division. And since it's division, I'm going to undo this by multiplying both sides by 3. So I'm going to multiply by 3 here, multiply by 3 here, so that 3 goes into itself. And I'm left with x equals 9 times 3 is 27. So now I'm going to go ahead and do step 5 again, which is not written. So when I solved it, I found that x equaled 27, but I have to do step 5, which is a check. And I'm going to do the check right here. So let's start with my original problem, which is x over 3 plus 1 equals 10. And I found x to equal 27. So I'm going to insert 27. Notice again, I'm using parentheses for the value that I'm inserting. 27 over 3 plus 1 equals 10. And I still have to follow order of operations when I'm solving these. So I end up with 9 plus 1 equals 10, and 10 indeed does equal 10. Check, I'm good. So this works out as well. So since I have your attention before I go on to the next thing, I just want to make a couple of notes on the side, and if you want to add these to your notes, you can. So firstly, just a quick reminder that we are using a reverse GEMDAS when we are solving equations. I want you to pay close attention. So pay attention to the signs. That's really important. And then also, please, when you're doing the check, always plug in with parentheses. It really will help you avoid some errors with negative numbers when we're dealing with negative numbers. So it really will help with that. And then finally, just remember that you are aiming to isolate the boxed variable. That is the big aim behind solving equations. You are aiming to get the boxed variable isolated. And just going back to my bestie and acquaintance example that's up here, we want to make sure we are getting rid of the acquaintance first before we get rid of the bestie. So just remember that we are doing that as well. We're going to look at another example, and let me switch pages here. This particular case, this is a special case where the entire quantity is. So here's example 4, and this is a very special kind of example. There's something unique about this, and what's unique about this is if you take a look at it, you'll notice that this fraction bar right here, sorry, it's not coming very as dark as I'd like it to. This fraction bar right here is such that it is extending over the entire numerator. So the entire numerator is x minus 1, and that whole quantity is being divided by 8. So that's really important and really critical. So this is a very special kind of equation that we're solving, and this is the kind where it is we're going to vary a little bit from the rules that we've been using just because of what this equation means. So my first recommendation to you with a problem like this is to go ahead and assume parentheses around the entire numerator. Assume that it is one complete unit, one term that is being divided by 8. In many ways, it is really the equivalent of, this is really the equivalent of a variable being divided by a number. So that's really how we need to treat this. Because we are going to we are going to put the entire numerator as 1 unit. So it's almost like it should have come with parentheses in the numerator to begin with, and it didn't. So we're going to just go ahead and add those in, because we know that this means this entire numerator is being divided by 8. So I cannot actually split these apart right away by taking away the 4. I cannot actually undo addition or subtraction first in this case. So I'm going to start and go through this problem. So this one is x minus 4, and that entire quantity of x minus 4 is being divided by 8, and that equals 2, just like that. I am going to go ahead and put those parentheses around this, like I suggested that you do. So I do recommend that you put those parentheses around this. And this time, so we're going to start by boxing our variable. So there's our variable. I am going to box it. I am also going to make that line that I usually make when I'm solving problems. And this time, I am not going to, let me use black. I am not going to undo addition or subtraction, because that addition or subtraction is actually more tightly connected with the numerator, since that entire quantity is being divided by 8. I am instead going to undo multiplication or division first. And we only do this in these unique cases when the entire numerator is being divided by a number. So I'm going to undo multiplication or division, and this is being divided by 8. So I'm going to undo that by multiplying by 8. So my step really here is multiply both sides by 8. And when I do that, I end up doing this times this, and you can see that it's in red. So you know that's the step that I'm performing, which means 8 goes into itself. They can cross each other out. And now I'm left with x minus 4 equals 16. And now I can go ahead and I can drop off those parentheses. So I can actually go ahead and drop off. Let me see if I can find an eraser. Will that do it? Yep, that'll do it. There we go. All right, so, and now I'm down to x minus 4 equals 16. I can now undo any addition or subtraction. So I will add 4 to both sides, add 4 to both sides. And when I do that, I'm left with x equals 20. And like always, I will do a step 5. So I found x to equal 20. I will do a step 5, which is to check. Sorry, I miswrote here. Step 5 is to check. And then my check is going to be that it's 20 minus 4, that entire thing divided by 8, and I'm wondering if it equals 2. And so if we solve this using our order of operations, we can see that 20 minus 4 is 16. I end up with 16 over 8, and I'm wondering, does that equal 2? 16 over 8 is indeed 2, so 2 does equal 2. Check, we're good. Just to actually show you what would happen if we didn't do it in this manner, if we did it in the manner that we've been doing the previous problems, to see what would end up happening and how when you do that, a check really helps you catch the error that you make. I am going to do it the wrong way. So this is going to be the wrong way that I'm showing you next. So wrong way. So this is just to prove. So it's just to prove why we need to undo multiplication or division when the entire numerator is divided by a number. Okay, so I am going to do it the wrong way so that I can prove why we need to first undo multiplication or division when the entire numerator is being divided by a number, as opposed to undoing addition or subtraction. So So this was really done. I just did this one in this manner to prove to you that if you did it incorrectly and then you did the check, you would find that both sides don't balance out. So that way, hopefully, you would get triggered to stop and think about, well, what went wrong? What changed? And then hopefully you will notice that it being, oops, sorry, it didn't